This is 7.2, Day 1, Part 2. Alright, so I was just talking about this process called upside down division and how I'm really trying to simplify this radical and I'm trying to pull out a perfect square that I have. Now, the reason I need a, well, here's a shortcut. So, if I have a pair of something, I put 1 in front, and I'm looking for a pair because it's a square root. This will be better described if I have a larger number, so let me do the next example and I'll say more. Okay, so let's say I had 243. 2 doesn't go into it, but 3 does, so 3 can divide into 243. The answer is 81. Divide by 3 again, I get 27. Divide by 3 again, I get 9. Divide by 3 again, and I get 3. Alright, so I'll show you the long way and then I'm going to show you a shortcut. So this again really means the square root of 243 is 3 times 3 times 3 times 3 times 3. This part right here would be the square root of 9. This part right here would be the square root of 9. So I've got 3 times 3 square roots of 3, so 9 square roots of 3. Here's the shortcut. Because it's a square root, I need a pair of 2 in order to cancel out the root, basically, or two numbers multiplied together in order to be able to find the square root of it. So my shortcut is, I'm looking for pairs of 2. Anytime I have a pair of 2, I put 1 in front of the radical, and then my little leftover goes underneath the radical. Things that are together in front are multiplied together, and things that are together underneath are multiplied together. Let's do the next example. So 750 can be divided by 2. The answer is 375. Can be divided by 5. The answer is 75. Can be divided by 5 again. The answer is 15. Can be divided by 5 again. And the answer is 3. Now, for this problem, it's actually a cube root. So, in order to find a number that I can pull out, I need something that I can take the cube root of. So I just want to again show you the long way, and then I'll give you a shortcut. 5 times 5 times 5 is 125, and the cube root of 125 is 5. Now, 2 and 3 are left underneath. I multiply them together to get 6. So here's the shortcut. Because it's a cube root, I need a group of 3 in order to put 1 in front. And then I had 2 different leftovers this time, so both of my leftovers went underneath and they're multiplied together. So 5 cube roots of 6 is my final answer. Let's do part D. Now for part D, I'm looking for a 4th root. So I'm going to need a group of 4 in order to put a number in front. I'm still doing upside down division. Now this one you may have had to test a few prime numbers before figuring out what the factor is, but it can be divided by 7. And you could have started with 3 as well, but I divide by 7 and I get 81. Divide by 3, I get 27. Divided by 3, I get 9. Divided by 3, I get 3. So now this time, because it's a 4th root, I need a group of 4 in order to cancel out the root. So I need a group of 4 in order to put 1 in front, and then this time I have a leftover of 7 underneath. And again, if you want to see it longhand, what's happening is that I have the 4th root of 81, because 3 times 3 times 3 times 3 is 81, times the 4th root of 7, and we're just finding the 4th root of 81 there. Go ahead and pause and try E and F. Okay, you have unpaused and you're checking your answer right now. You should end up for E with 2 in the 5th root of 15. So I'm just going to quickly go through this and show you how I got that. Again, you can ask questions in class if you're confused on this. And it is a 5th root, so I'm looking for a group of 5 to put 1 in front, and then 3 and 5 are my leftovers that I put underneath multiplied together. For F, the correct answer is the cube root of 100. This one can't be simplified. Here's why. If I try to find my factorization here, I actually do not end up with any number that has a group of 3, and I needed a group of 3 to simplify, so this one actually cannot be simplified anymore. And that does happen sometimes. Alright, I needed to show you that because we're going to use that often when I'm trying to use those properties of radicals I showed you in the first video. So let's look at example 3. I'm trying to simplify by using properties of radicals. And these problems have more than one correct method of doing this, so it's okay if you go about it a slightly different way than me, as long as we both get the correct same answer. In this situation, I'm going to use the property that I can multiply 4 and 16 together underneath a radical. And so that ends up being the cubed root of 64. And actually, if it is a root you know, take it. So cubed root of 64 is actually something I could just use in my calculator, so I'm just going to go for it. Of course, if you wanted to, you could have done your upside down division process. And what's happening here is I'm ending up with, oh, you know what? I just made a mistake. Did you see what mistake I made? Okay, maybe not, but anyways, it's a cube root, so I'm looking for groups of 3. And when I started out, I circled groups of 2. Oops. Alright, so I've got a group of 3 which is 1 in front, another group of 3 which is 1 in front, there's nothing left, and the answer is 4. Let's look at part B. So again, use our property of radicals. This time I'm going to use a property that a fraction like that can be put together, and this helps me because 162 divided by 2 is 81, and the fourth root of 81 is another one we know. If you test it in your calculator, the answer is 3. Go ahead and pause the video and try C and D. If you have unpaused and you're checking your work, you should end up with 5 for C and an answer of 2 for D. Alright, that is all for properties of rational exponents, day 1. We will do the second page for day 2 videos.